Hi student, in last lecture we start our new chapter, that is matrices, and in this lecture we have studied types of matrices and what is meant by matrix. Now in this lecture we are going to study algebra of matrices. Now in this point we see transpose of a matrix, symmetric matrix, skew symmetric matrix, equality of two matrices, addition of two matrices, and scalar multiplication of a matrix. So first point we see, that is transpose of a matrix. So look at this first point, transpose of a matrix. So what is mean by transpose of a matrix? Let's consider a matrix A. Aij is of order m by n. That means the matrix A having m order and n rows. Now we have to find the transpose of a matrix. So what is mean by transpose? In 11th standard we already studied the transpose. Now transpose of a matrix can be obtained by replacing rows and columns. So the transpose of a matrix, can be obtained by interchanging rows and columns. That means rows are converted into column and columns are converted into rows. If a matrix having order m by n, then the transpose of a matrix having order n by n, and the transpose of a matrix is denoted by A dash or A complement. Suppose we take for example, so here order of A is m by n, then the order of its transpose, A transpose, is equal to suppose here Aij, and the order of this matrix is n by n. So here we write A dash or simply A transpose, not A. This is the symbol A transpose, or it is A dash. If order of A is m by n, then order of its transpose matrix is n by m. So remember, suppose for example A is equal to 1, 2, 3, 3, 2, 1. This matrix having order 2 by 3. Since this matrix having 2 rows and 3 columns, so we obtain its transpose. Therefore, A transpose is equal to what? What is meant by transpose? Interchanging its rows and columns. That means columns are converted into rows and rows are converted into columns. So this 1, 2, 3 is our first row. So this row becomes first column. 1, 2, 3, and this is our second row. This becomes second column. So now order of this matrix A transpose having 3 rows and 2 columns. So this is a transpose of a matrix. So first point is transpose of a matrix. This is all about the transpose of a matrix. Now what is second point? That is symmetric matrix. We see symmetric matrix. And next second point is skew symmetric matrix. In exam there will be asked the question, find the values of any point or any unknown which are given in the matrix, if the given matrix are symmetric or given matrix are skew symmetric. First of all we see what is meant by symmetric and what is meant by skew symmetric. So first we see symmetric matrix. So a square matrix. Symmetric matrix is also a square matrix. Square means the order of rows and columns are same. The square matrix A is equal to Aij, in which Aij is equal to Aji for all Ij. Means every value of I and j, there will be Aij is equal to Aji. So for example, we take a matrix. Suppose A is equal to AHG, HBF, GFC. This is a standard matrix. The matrix is a standard matrix. Now look at here. The ABC are diagonal elements of this matrix. ABC are diagonal elements of this matrix, and here this is the value of A12 which is equal to A21. Now this is the value of A13. Again this is the value of A31. This is the value of A3, A23. This is the value of A32. The corresponding values are same. That is Aij is equal to Aji. These matrices are called as a symmetric matrix. Now next matrix is there, skew symmetric matrix. So what is meant by skew symmetric matrix? Skew symmetric matrix. Skew symmetric. Again it is a square matrix. A square matrix A is equal to Aij, in which Aij is equal to minus Aji for all Ij. Both these matrices are same where Aij is equal to Aji, but in skew symmetric the sign it changes only. There is difference in only sign. So for example, A is equal to 1, 3, 2, then minus 3, 4. Again here we take minus 3, so here is minus 2, then 5 and minus 5 and 6. Now look at here. What is value of A12? A12 is equal to 3 and A21 is equal to minus 3. Again next, A13 is equal to 2 and A31 is equal to minus 2. A32 is equal to A23 is 5 and A32 is equal to minus 5. That means what is meant by skew symmetric matrix? The elements are same but only sign changes. There is only sign is changing. So A12 is 3, then its A21 is minus 3. This is plus 2, this is minus 2. So difference between symmetric matrix and skew symmetric matrix. In symmetric matrix, elements are same. Which elements? That is Aij is equal to Aj. That corresponding elements are same in symmetric matrix, but in skew symmetric there is only changes in sign. So don't forget this point, symmetric and skew symmetric. In exam we have to ask the question, find the value of k if given matrix is skew symmetric. Here instead of minus 2 we have to give one the value of k, and given that this matrix is a skew symmetric matrix, so we write this matrix is a symmetric matrix. Therefore what is value of k? That is A32 is equal to A23. Therefore value of A32 is 5. Therefore value of A23 is minus 5. So this is a question asked in these two type of a matrix, symmetric and skew symmetric. Next point is there, equality of two matrices. So there are some properties on transpose of a matrix. If we have a matrix A, 1, 2, 3, 2 and 4, 5, which is of order 3 by 2. 3 rows and 2 columns. Then its transpose, A transpose is equal to this row, column becomes row 1, 3, 4, 2, 2, 5. So order of this matrix is 2 by 3. Again I am taking transpose of this matrix, A transpose. So again rows are converted into columns. So 1, 3, 4 is row, column here. So row here, and in this matrix it becomes row. So 2, 2, 5. Again it is order of this matrix is 3 by 2. So which is equal to, we get matrix A, which is a matrix A. So first property of transpose of a matrix, if we take transpose of any matrix, then we will get a matrix itself, that is A transpose of transpose. is equal to A itself. That is first property of a transpose. And if our A is a symmetric matrix, if this A is a symmetric matrix, then A is equal to A transpose. If matrix is symmetric, then the value of matrix A and A transpose always same. Next, if B is skew symmetric, if B is skew symmetric, then B is equal to minus B transpose. There is change in only sign, not the matrix. If A is symmetric, then A is equal to A transpose. But if this B is a skew symmetric, then B is equal to minus B transpose. Now we see next point, that is equality of two matrices. Equality of two matrices. When two matrices are said to be equal. When two matrices are said to be equal, if first order of matrices are same, and second condition, corresponding elements are also same. Two matrices A and B are said to be equal matrix, equal matrix if, when first condition, order of A is equal to order of B, means in equal matrices order of both matrices are same. And second one important condition, corresponding elements are also same. Corresponding elements are same. That means, for example, A is equal to 1, 2, 3 and here 3, 2, 1. And B is equal to, I am taking matrix 1, 2, 3 and 3, 2, 1. So here order of A is 2 by 3 and order of B is 3 by 2. Is order of these two matrices are same? No. Order of A is 2 by 3 and order of B is 3 by 2. So first of all, order of matrices are not same. Then we don't check whether elements are same. If order is not same, then the two matrices are not equal. These two matrices are not equal. Also, if order is same, if it follows first condition, then we see second condition. What is second condition? Corresponding elements are also same. The elements which are in A and B both are same. So, for example, A equals to AB, CD and B equals to also AB, CD. Order is 2 by 2 and here order of B is also 2 by 2. Here order of both AB are same and also corresponding elements of A and B are same. Hence we can say that these two matrices A and B are equal. If order is same but elements are not same, then the matrix does not said to be a equal matrices. Now next point is the addition of two matrices. Addition of two matrices. First point. Addition. When addition of two matrices A and B, we are taking if first A and B are two matrices. A and B are two matrices. Then if we have to take addition of these two matrices A and B, first of all order of these two matrices are same. Important condition is that order of A is equal to order of B. Then addition of two matrices is denoted by A plus B. Addition is denoted by A plus B. Suppose, for example, A is equal to 1, 2, 6, 4 and B is equal to 3, 5, 7, minus 2. Both matrix having order 2 by 2 or which is of order 2. Now we have to add in A plus B. So I am writing here A plus B is equal to, write these two matrices 1, 2, 6, 4. First write A, then the plus sign as it is. Now writing B, 3, 5, 7, minus 2. Now add corresponding elements. That is A11 plus A11 of matrix B, that is 1 plus 3 corresponding elements. Next 2 plus 5. Next 6 plus 7 and here 4 plus of minus 2 is equal to 1 plus 3 4, 2 plus 5 7, 6 plus 7 13 and this 4 minus 2 is minus 2. If A and B are of same order, then A plus B having also of order, and if A and B having order n, then A plus B also having order n. Here A and B both are having order 2, therefore also A plus B having order 2. So this is an addition of two matrices. Now we see properties of addition. Properties of addition. Which properties of matrices are satisfied? So properties of addition. So first property is there, A plus B is equal to B plus C. It is called as commutativity. It is called as commutativity. It is addition. So I am taking 2 plus 3, that is 5, and again 3 plus 2, which is also 5. So here same, A plus B is equal to B plus A, that is it is called as a commutativity. Next, second one property is that A plus B plus C is equal to A plus B plus C, which is called as a associativity. Which is called as a associativity. Now third property is that A plus 0 is equal to 0 plus A. If in matrix A we are adding 0 matrix, then we get a matrix A. So this 0 is called as a addition or additive inverse. Now next one we take 0 into A here. These are some properties. Or if we multiply any scalar, if we multiply by any scalar, that is alpha and A into beta, then we will get alpha A into beta. This is called as a scalar multiplication. Now in next point we see what is meant by scalar multiplication. So what is scalar multiplication? If we have given any matrix and any scalar k, then the scalar is multiplied by each element of the matrix. It is called as a scalar multiplication. Now next point we are going to see, that is scalar multiplication of a matrix. Scalar multiplication of a matrix. Scalar multiplication of matrix. Let A be any matrix. A be any matrix. And K is any scalar. Scalar means constant. K is any scalar. Then the scalar multiplication or the scalar matrix can be obtained by multiplying. Then the scalar multiplication means what? Scalar are multiplying by each element. multiplying by each element of a matrix A. Each element of a matrix A. Then we obtain a scalar multiplication. Suppose, for example, we take, for example, A is equal to 1, 2, 3, 4. This is matrix A, and K is equal to, suppose we take 4. Then find K into A. Then find K into A. So here K is a scalar and A is our matrix of order 2 by 2. So finding Ka, right? Ka. So put the values of K and A. What is value of K? 4. Into that A, 1, 2, 3, 4. Now scalar multiplication means what? We have to multiply the scalar by each element of a matrix. That is 4 into 1, 4. 4 into 2, 8. 4 3s are 12. 4 4s are 16. So this is a Ka, which is a new matrix, and it is again of order 2. That is same order. If we multiply a scalar by any matrix, then the order of matrix cannot be changed. This is called as a multiplication of a scalar by any matrix. Now in next lecture we see some examples which are depending on this algebra of matrices. So thank you.